Hey guys, I hope that the multiplication and division with rational expressions has gone well, and we're going to move into adding and subtracting expressions. So similar to what you see here on the screen. Before we can get to something this complicated, I want to kind of start with the basics. So just a quick reminder of what happens when we have two fractions added together. As long as we have the same denominator, right? So both of these fractions are something over 9, so we have 1/9 and 4/9. The way we think about that is since we have the same denominator, all we have to do is keep that denominator the same, and we add the top to get 5/9. So pretty simple process. So let's take a look at this if we're looking at rational expressions instead. So here we have two rational expressions. They both have the same denominator. I have 2x minus 5 on the denominator of both fractions. So what this means is I can basically write it as a new fraction that has 2x minus 5 as the denominator, and whatever's on the top comes from literally just combining the two numerators, okay? And we would just combine like terms. So I know that I have 1x squared plus 6 more x squared, which is going to give me 7x squared. I have a plus 3x, and there's no x, so I'm going to have plus 3x. And I have a minus 7 with a minus 12, which combines to be minus 19. And again, the denominator stays the same because that's how we add fractions, and we get 2x minus 5. So the simple combination of rational expressions when I have the same denominator is pretty straightforward. I have the same denominator, so all I have to do is add across the top with combining like terms. So let's look at a subtraction problem, which is going to be slightly more complicated, but not really. Here again, I have the same denominator, so I already know that my answer is going to have 5x squared minus 6 in the denominator. But one thing to remember is when we have a fraction, everything in the numerator is grouped together. So just like we did before we did fractions, if I'm subtracting this minus this second polynomial, this minus sign has to be distributed to all three terms. So I'm going to rewrite this in a new way that says 3x squared plus 6x minus 4. And then since I'm going to distribute, I'm going to write this as minus x squared. When I have a negative times a negative, it becomes plus 3x. And when I have a minus times 9, it's going to become minus 9. So I've distributed the negative to all of the terms. And of course, like I said, the denominator stays the same. So now that I've rewritten this, I can think about combining like terms. Again, we have 3x squared and minus x squared. 3 minus 1 is 2x squared. Next, I go to this x term, so plus 6x and plus 3x is plus 9x. And here we have minus 4, minus 9, so negative 4 minus 9 would become minus 13. And again, this is all over our original denominator. Nothing had to change because my denominators were already the same. So hopefully these problems aren't too bad. If I already have a common denominator, all I'm literally doing is adding or subtracting like we did in the first week of school, combining like terms, and keeping the denominator the same. So not too bad. Remember though, when fractions can get a little trickier is when I don't already have a common denominator. So for instance, in this case, I have 3/8 and 2/5. I can't combine eighths with fifths, right? If you think about it in terms of like, if you pictured like a pie or something, I can't combine number of pieces and say how many pieces I have if the pieces aren't the same size. So when we have different denominators, what we do is we have to get a common denominator, and we do that by multiplying by the denominator that's the factor that's missing. So in this problem, I would take my left fraction and I would multiply by 5 over 5. Because this denominator is 5. And the reason we multiply by the same number on top and bottom is because 5 divided by 5 is 1, and we know 1 times anything doesn't change, it stays the same. So we're just rewriting the way this looks, we're not changing the actual number. And so same thing over here, I need to multiply by the other denominator, which would be 8 over 8. And so this, my new problem would be 5 times 3 is 15. And obviously 5 times 8 is 40. And here I would have 2 times 8 is 16. And 5 times 8 is 40. So now, so again, 16 over 40 is the same number as 2/5. If you want to pause this and put it in the calculator, you can see when you divide 16 over 40, you get 0.4. And the same thing happens when I do 2 divided by 5. So I haven't changed the original problem. I've just changed the way it looks. And now the denominators are the same value. So I can do this just like the last one. So I know my answer is going to be something over 40. And 15 plus 16 is equal to 31. So there's my answer. So let's kind of take this concept and apply it to rational expressions instead of just fractions. Hopefully this seems kind of familiar. Here is an example of a rational expression that has different denominators. So again, since these denominators are not the same, I cannot just add across the top like I did in the beginning, right? You can't say 3x plus x is 4x minus 1 because the denominators aren't the same. That would be a bad idea. We cannot do that. So I need to erase that. So what can we do? Again, just like we do with the fractions. If I have different denominators, I need to look at the other denominator. So this one has x plus 2, this one has 2x. I need to get the same factors on the denominator of both. So this one has x plus 2, I'm going to multiply by 2x. And whatever I do on the bottom, I have to do on the top so that I'm multiplying by 1. On this side, it's missing the x plus 2, so I'm going to multiply by x plus 2 on the top and the bottom. Okay, so what we have to do now, so now if I were to simplify this left fraction, 2x times 3x is 6x squared, right? And the denominator is 2x times x plus 2. On this other side, I have x minus 1 times x plus 2. So I'm going to have to do distributive property here, right? X times x is x squared, and x times 2 is 2x. And minus 1 times x is minus x. And minus 1 times 2 is minus 2. And on the bottom, I also have 2x times x plus 2. So now we can see our two expressions have the same denominator. Once we have the same denominator, I know that I can just combine like terms on the top, and my denominator is going to be 2x times x plus 2. And you can just leave it factored like that. So now I'm combining like terms. 6x squared plus x squared is 7x squared, right? 2x, positive 2x, and minus 1x is plus 1x. And of course, I have minus 2 left. And so at this point, we're done. So not a whole lot harder, but we do have to do this extra step in the beginning to get the common denominator, and then it's just like the problems we did earlier in this video. Let's take another look at one more that is slightly more complicated. Okay, so what's the story here? This looks way more complicated because the denominators are much larger. All right, so what we could do is multiply this denominator x squared plus 5x plus 4 by all of this other one. But you're going to get a big, long, nasty expression. So anytime we have something on the denominator that looks more complicated, our first step is going to be to try to factor. Okay, just like we did when we were multiplying and dividing. Why do we not factor on this last problem? Well, because 2x and x plus 2 are so simple they can't be factored. But if you have a more complicated expression, we want to factor first. So again, I'm looking for numbers that multiply to be 4 and add to 5. So that would be x plus 4 and x plus 1. 4 plus 1 is 5. 4 times 1 is 4. Here, I'm looking for numbers that multiply to be negative 8. So I would have x and x multiply to be negative 8 and add to be 2. So I would need a plus 4 and a minus 2. Okay, so I'm going to rewrite this problem as x plus 2 over x plus 4 times x plus 1. And then this expression is 3x over x plus 4 times x minus 2. Okay, the reason we like to rewrite it this way in factored form is because it allows us to see that these denominators have something in common already. So I don't need to multiply each fraction by the entire other denominator. I only need to multiply by the factor that's missing. Remember, the whole goal is to have the same factors on both denominators. So this one has an x plus 4. This one also has an x plus 4. So that's already common. We only need to multiply by the thing that's not common. So this one on the left does not have an x minus 2. So I'm going to multiply by x minus 2 on my left equation on the top and the bottom, right? My right equation is missing an x plus 1. So I'm going to multiply by x plus 1 on the top and the bottom. And so you can kind of see already now these two expressions have the same thing in the denominator. I have an x minus 2, an x plus 4, and an x plus 1. And I have that in both of them. Okay, so all I have to do to finish, now that I have the same denominators, is go ahead and distribute everything on the top so that I can combine my like terms and be done. So first things first, x times x is x squared. And then I have a plus 2x, and I have a minus 2x, and a minus 4, right? And over here, and that's over all this x minus 2, x plus 4, and x plus 1. Okay, and over here I have 3x times x is 3x squared. And when I do 3x times 1, I get plus 3x. And again here I have the same denominator. Okay, so we have x plus 4 and x minus 2 and x plus 1 on my denominator. Okay, so last step, all I have to do again is combine like terms. So I have x squared and 3x squared being added together. So that gives me 4x squared. I have 2x minus 2x, that equals 0, plus 3 more x, so I have a plus 3x. And then last I have a minus 4. This one doesn't have a constant to combine with, so I get minus 4. And so my final answer is 4x squared plus 3x minus 4. And my denominator is all this stuff, which again, I'm just going to leave in factored form. There's no reason to multiply all that out. Okay, so this is a little more complicated, but not something we can't handle, hopefully. We just have to, again, so if I could summarize this, let's do that real quickly. The idea, maybe on the side, okay, is I want to factor first to kind of see what's common and what's not common, okay? Then I'm going to multiply by whatever factors are not common so that I get the same denominator that aren't common, okay? And you can kind of see what we did here on the left to match with this. We factored right here. We saw that this one was missing an x minus 2. We saw that this one was missing an x plus 1. So I multiplied those missing factors, and that gave me the common denominator, so that at the end, all I have to do is multiply the top out and combine like terms. So it's not the easiest thing we've ever done probably, but I think it is something with some practice that we can be pretty good at. And it's more factoring to practice. If you want, you can stop the video right now. If you want to watch one more example, here's one. You can just pause it maybe and try it on your own, and then I'll do it real quickly if you want to check yourself. Okay, so I'm hoping you gave this a chance and pause it to practice. So I'm going to do this fairly quickly just to kind of you can see if you can check your work. So first things first, I'm going to factor the bottom. So I'm looking for numbers that multiply to be negative 18. So x minus 6 and x plus 3, because negative 6 times 3 is negative 18, and minus 6 plus 3 would be minus 3x. Over here, how would this factor? It would be numbers that multiply to be negative 36 and add to be 0 because there's a missing term. This is our difference of two squares. X times x is x squared, minus 6 and plus 6 is 36, negative 36. So now I know, here's my equation. I have 4x over x minus 6 times x plus 3 minus x plus 1 over x minus 6 times x plus 6. Okay, so what is missing? This one on the left does not have an x plus 6, so I'm going to multiply on the top and bottom by x plus 6. The one on the right is missing x plus 3, so I'm going to multiply by x plus 3 on the top and the bottom. Okay, now I have the same three factors in both expressions. All I have to do is multiply the top, distribute out, and combine like terms. So 4x times x is 4x squared. 6 times 4x is 24x. And again, it's all over x plus 6 and x minus 6 and x plus 3. And then I have minus. When I distribute, I have x squared plus 3x plus 1x plus 3. And again, it's all over x plus 6 and x minus 6 and x plus 3. Remember, the order doesn't really matter here. Okay, so last step is combine like terms, but be careful. This one's a subtraction problem. So remember, this negative sign needs to be distributed to everything in the top. So it changes the sign of all of these things. You can write this as a separate step, or you can just change this. This becomes a minus. This becomes a minus. This becomes a minus. Okay, so our final answer is 4x squared minus, right, minus 1x squared, which becomes 3x squared. I have 24x minus 3x is 21. Minus one more is 20x. And then I have no constant with just a minus 3 at the end. And so this would be our final answer. I hope that makes sense. I'm going to put a link in this Google Classroom assignment or whatever you call this, a material, that to some more videos, maybe with Khan Academy or something, in case you want to see more. Or send me a text and I'm happy to help. Hope you guys are having a great day, and I'll see you on Monday. Thanks for watching.